Problem number 1. We have the differential equation derivative of y with respect to x equals cosine cube x times sine squared x plus x times square root of 2x plus 1. So first what we will do, we will separate the differentials to get dy equals cosine cubed x sine squared x plus x times square root of 2x plus 1 whole multiplied to dx. Now this particular equation is in the separable form, so we can integrate both sides to get integration dy is equals to integration cosine cube x times sine square x dx plus integration x times square root of 2x plus 1 dx. Let us consider the first integral as I1 and the second integral as I2. Now we will start computing the first integral, so I1 will be equals to cosine cube x times sine squared x dx. So this can be rewritten as integration cosine squared x times sine squared x times cosine x dx. So here we have written cosine cube x as cosine squared x times cosine x, so that we can replace cosine squared x with 1 minus sine squared x, and that gets multiplied to sine squared x times cosine squared x dx, or simply integration of sine squared x minus sine x whole raised to the power of 4 whole multiplied to cosine of x dx. Now we're going to perform an integration by this method of substitution. Let's consider sine of x is equals to t. Taking the derivative on both sides with respect to x gives us cosine of x dx equals to dt, such that our integral I1 becomes integration t squared minus t raised to the power of 4 times dt, or simply integration t squared dt minus integration t raised to the power of 4 dt. Using the power rule, we get 1/3 of t cubed minus 1/5 of t raised to the power of 5 plus the constant of integration c1. Therefore, I1 becomes 1/3 of sine cubed x minus 1/5 of sine x whole raised to the power of 5 plus c1. Coming to the second integral, I2 is equals to integration x times square root of 2x plus 1 dx. So we will perform this particular integration by the method of substitution. Let's assume that 2x plus 1 is equals to a variable t. Now differentiating both sides with respect to x gives us 2 times dx is equals to dt, or simply dx is equals to half dt. Isolating x, we get half of t minus 1, such that our integral I2 now becomes integration. In place of x, we have half of t minus 1 times square root of 2x plus 1 gets replaced with t times we have dx, which gets replaced with half dt, or simply put, it becomes 1/4 integration of t times square root of t minus square root of t dt, or simply 1/4 times integration t raised to the power of 3/2. So here we have combined t times square root of t dt minus 1/4 of integration t raised to the power of half dt. Using the power rule, we have 1/4 of t raised to the power of 3/2 plus 1 will be 5/2 divided by 5/2 minus 1/4 of t raised to the power of half plus 1, so that is 3/2 divided by half plus 1, which is also 3/2, plus the constant of integration c2, and that gives us 1/10 times t raised to the power of 5/2 minus 1/6 of t raised to the power of 3/2 plus c2. Now replacing the value of t with 2x plus 1, so we have I2 is equals to 1/10 of 2x plus 1 raised to the power of 5/2 minus 1/6 times 2x plus 1 raised to the power of 3/2 plus c2. Finally, we have integration of dy, which is equals to the two integral I1 plus I2, so replacing them with the value that we have just found out, so we finally get y is equals to 1/3 of sine cube x minus 1/5 of sine x raised to the power of 5 plus 1/10 times 2x plus 1 raised to the power of 5/2 minus 1/6 of 2x plus 1 whole raised to the power of 3/2 plus c, where c is c1 plus c2. So this is the required solution to the given differential equation. Problem number 2. So here we have the differential equation sin x plus cosine of x times dy plus cosine of x minus sine of x times dx is equals to 0. So we begin by separating the differentials. So that gives us dy is equals to negative of cosine of x minus sine of x divided by sine of x plus cosine of x times dx. So this is now in the separable form. Hence we can integrate both sides, and that will give us integration dy is equals to negative integration of cosine x minus sine x divided by sine x plus cosine x integrated with respect to x. Now we're going to perform the integral on the right hand side by the method of substitution. So let's take the denominator sine x plus cosine of x is equals to a variable u and differentiated both sides with respect to x to get cosine of x minus sine of x times dx is equals to du. So that gives us integration of dy will be y will be equal to negative of integration. So the numerator cosine x minus sine x whole times dx will become du divided by our variable u. And we know that integration of du over u will be natural log of u. So we get negative natural log of u plus c, or simply y is equals to negative of log of sine x plus cosine x plus the constant of integration c. Problem number 3. Here we have the differential equation derivative of y with respect to x equals to x times sine squared x plus 1 over sine x. So let's begin by separating the differentials. We have dy is equals to x times sine squared x plus 1 over x log x whole multiplied to dx. Now this is in the separable form. So we're going to integrate both sides, and that should give us integration dy is equals to integration x sine squared x dx plus integration of dx over x log x. Now let's consider the first integral as I1 and the second integral as I2. We begin with the first integral. So I1 will be equals to integral x sine squared x dx. Now we're going to use the identity sine squared x is equals to 1 minus cosine of 2x divided by 2, such that we have x times 1 minus cosine of 2x over 2 dx, or simply put half of integral x dx minus half of integral x times cosine of 2x dx. The half of integral x dx will be simply x squared over 2 minus half. Now we have x times cosine of 2x. So let's integrate it by parts by considering x as the first function and cosine of 2x as the second function. So that should give us x times integration of the second function minus integration of derivative of the first function times integration of the second function whole integrated with respect to x. And that should give us x squared over 4 minus half multiplied to x times integration of cosine of 2x will be sine 2x over 2 minus integral. So derivative of x with respect to x is 1 and derivative of cosine 2x will be half sine 2x, such that we get. Then again, integrating sine 2x with respect to x gives us negative cosine 2x over 2 plus the constant of integration c1, and that gives us I1 is equals to x squared over 4 minus x over 4 times sine 2x minus 1 over 8 times cosine 2x plus c1. Now we compute the second integral, which is integration of dx over x natural log of x. Let's perform this integration by the method of substitution. We're going to assume that natural log of x is equals to a variable t. Differentiating both sides with respect to x gives us dx over x is equals to dt, such that the integral becomes dt over t. The integration of dt over t will be natural log of t plus another constant of integration c2, and replacing t with natural log of x we have log of log x plus c2. Thus integration of dy, which is equals to y, was I1 plus y2. So that is simply x squared over 4 minus x over 4 sine 2x minus 1 over 8 cosine 2x plus natural log of x plus c. So this is going to be the required solution to the given differential equation. Problem number 4. So here we have the differential equation sine x whole raised to the power of 4 times derivative of y with respect to x is equals to cosine of x. So we begin by separating the differentials, and that should give us dy is equals to cosine of x divided by sine x whole raised to the power of 4 times dx. Now this is in the separable form. Now we're going to integrate both sides. That should give us integration dy is equals to integration of cosine x divided by sine x whole raised to the power of 4 integrated with respect to x. We're going to integrate the integral on the right hand side by the method of substitution. For that, we're going to assume that sine x is equals to t. Differentiating both sides with respect to x gives us cosine x dx is equals to dt, such that our integral now becomes integration dt over t raised to the power of 4. Hence we have y is equals to t raised to the power of negative 4 plus 1 divided by negative 4 plus 1 plus the constant of integration c. Here what we have done is used the power rule, and that finally gives us negative 1 over 3 t cubed plus c. T is simply sine x, so we have y is equals to negative 1 over 3 times sine cubed x plus the constant of integration c, and this is the required solution to the given differential equation. Problem number 5. Here we have the differential equation cosine of x times derivative of y with respect to x minus cosine of 2x equals to cosine of 3x. So let us begin by separating the differentials. We have dy is equals to cosine of 2x plus cosine of 3x divided by cosine of x all multiplied to dx. Now this is in the separable form. Now here what we're going to do, we're going to use the trigonometric identities. Cosine of 2x is equals to 2 times cosine squared x minus 1, and cosine of 3x is equals to 4 times cosine cube x minus 3 times cosine x. So that gives us, so in place of cosine of 2x we have 2 cosine squared x minus 1 plus cosine of 3x will be 4 times cosine cube x minus 3 cosine of x all divided by cosine of x dx. Or simply put, dividing each term in the numerator by cosine of x, we have 2 times cosine of x minus 1 over cosine of x will be secant x plus 4 times cosine squared x minus 3 all multiplied to dx. 2 times cosine of x minus secant x plus 4 times we have cosine squared x, which can be again replaced with 1 plus cosine of 2x over 2 minus 3 dx, or we do some little bit of more algebraic manipulation to get 2 times cosine of x minus secant x plus 2 times cosine of 2x minus 1 dx. Now since this is in the separable form, we're going to integrate both sides. So that should give us integration dy is equals to 2 times integration cosine of x dx minus integration of secant x dx plus 2 times integration of cosine 2x dx minus integration dx, which is equals to 2 times integration of the cosine function is sine x minus integration of the secant function is natural log of secant x plus tangent x. This is found from the table of integrals, plus 2 times integration of cosine 2x will be sine 2x over 2 minus integration of dx, which is simply x plus c. Therefore, y is equals to 2 times sine of x minus natural log of secant x plus tangent of x plus sine of 2x minus x plus c, and this is going to be the required solution to the given differential equation. Problem number 6. So here we have the differential equation square root of 1 minus x raised to the power of 4 all multiplied to dy is equals to x dx. Now we're going to separate the differentials. That should give us dy is equals to x divided by square root of 1 minus x raised to the power of 4 whole multiplied to dx, and this is in the separable form. So now we can integrate both sides, and that should give us integration dy integration of x dx over square root of 1 minus, so here x raised to the power of 4 can be written as x squared whole squared. This is done so that we can replace x squared with t and differentiate both sides to get x dx, which is the numerator. That will be half dt. And now integral now becomes integration dy is equals to half integration of dt divided by square root of 1 minus t squared. Now from the table of integrals, we know that integration of du divided by square root of a squared minus u squared is simply sine inverse of u over a plus c, such that y is equals to half sine inverse of t plus c. Now replacing t with x squared, we finally get y equals to half sine inverse of x squared plus the constant of integration c, and this is the required solution to the given differential equation. Problem number 7. So here we have the differential equation square root of a plus x whole multiplied to dy plus x dx is equals to 0. So let's begin by separating the differentials. So we have dy is equals to negative x dx divided by square root of a plus x. Now what we can do a little bit of algebraic manipulation. In the numerator we can add and subtract a such that we have dy is equals to negative of a plus x divided by square root of a plus x minus a divided by square root of a plus x whole multiplied to dx, or simply put dy is equals to negative of square root of a plus x minus a divided by square root of a plus x. Now since this is in the separable form, we can integrate both sides to get integration dy is equals to negative integration of a plus x raised to the power of half dx plus a times a plus x whole raised to the power of negative half dx. Integration of dy will be y, which will be equals to, using the power rule, we have negative 2/3 of a plus x whole raised to the power of 3 over 2 plus a times a plus x whole raised to the power of 1 over 2, and also it will get multiplied with the number 2 plus the constant of integration c, and this is going to be the solution to the given differential equation. Problem number 8. So here we have the differential equation 1 plus x squared multiplied to derivative of y with respect to x minus x equals to 2 times tangent inverse of x. So let's separate the differentials and write in terms of dy to get x plus 2 times tangent inverse of x whole divided to 1 plus x squared multiplied to dx. Now integrating both sides, we have integration dy is equals to integration x over 1 plus x squared dx plus 2 times integration of tangent inverse of x dx over 1 plus x squared. Now for the first integral, we are going to multiply and divide by the factor 2 such that we apply the method of substitution to get half natural log of 1 plus x squared plus 2 times. Now for the second integral, which is tangent inverse of x dx over 1 plus x squared, we're going to assume that tangent inverse of x is equals to t. Differentiating both sides gives us 1 over 1 plus x squared, which is the derivative of the inverse tangent function, equals to dt over dx, or we get dx over 1 plus x squared is equals to dt, such that our integral is converted into integration t times dt. Integration of t with respect to t will be half t squared plus the constant of integration c. Replacing t with tangent inverse function, we have 2 multiplied to half of tangent inverse of x squared plus the constant of integration c. Performing the required algebraic manipulation, now final answer will be half natural log of 1 plus x squared plus tangent inverse of x whole squared plus the constant of integration c. Problem number 9. So here we have the differential equation derivative of y with respect to x is equals to x e raised to the power of x plus cosine squared x. So let's separate the differentials and write in terms of the differential dy, we get x e raised to the power of x plus cosine squared x dx. We're going to further simplify the cosine squared x by using an identity. That will be 1 plus cosine of 2x over 2, such that we get x e raised to the power of x plus half cosine of 2x whole multiplied to dx. So this is in the separable form. Let's integrate both sides to get integration dy is equals to integration of x e raised to the power of x dx plus half integration of dx plus half integration of cosine 2x dx. Now integration of dy will be y, which will be equals to integration of x e raised to the power of x dx. Now this is integration by parts, which is a very simple integral, which gives us the value x e raised to the power of x minus e raised to the power of x plus half of integration of dx will be x, so we get x over 2 plus half of integration of cosine of 2x, that will be sine of 2x over 2, and that the 2 in the denominator gets multiplied with the factor half to get 1/4 of sine 2x plus the constant of integration c. So that is going to be the required solution to the given differential equation. Problem number 10. So here we have the differential equation. Derivative of y with respect to x is equals to x natural log of x. So let's write it in the separable form. So we get dy is equals to x natural log of x times dx. Now we're going to integrate both sides. Now the integral on the right hand side is a product of two functions, x times natural log of x. So here we need to integrate it by parts. So let's consider the natural log of x as the first function and x as the second function. So y will be equals to natural log of x multiplied to integration of the second function x dx minus integration of derivative of the first function, that is log of x, multiplied to integration of the second function x dx whole integrated with respect to x. So we get x squared over 2, which is integration of x times natural log of x minus integration of derivative of the natural log will be 1 over x multiplied to integration of x dx will be x squared over 2. The entire integral is integrated with respect to x. So the x and x gets factored out, and that leaves us with integration x over 2. So the final answer will be x squared over 2 times natural log of x minus half integration of x dx. So integration of x dx will be x squared over 4. Thus y will be equals to x squared over 2 times natural log of x minus x squared over 4 plus the constant of integration c.